In this lesson, we'll be looking at using logarithms to solve exponential equations. So essentially what we'll be looking at is how can we algebraically manipulate to get to a point where we can evaluate, calculate, and how do we use our graphics calculator in these scenarios as well. So that's our focus. To bring up logs on the graphics calculator, there's two ways. Now, in most calculators, you'll have a log button. So I'm sure you can see the button on your graphics calculator that says log. That one works in log base 10 specifically. The other option is if in your run menu, now you should be back at your main menu. If you're not, hit exit a couple of times and that'll make sure you're back. If you hit F4, you go into math. In that menu, you've got a bunch of different options. We want to choose the one that says log AB, so that's F2. And then we can do the log of any base. So we could say log base 2 of 8, and we should get 3 as our exponent there. Okay, so you can check all your evaluations on your graphics calculator, and in scenarios where it's not a perfect answer and they want a decimal solution, then you're going to use your graphics calculator to do that. Okay, so we'll start with a simple scenario. Remember, the whole idea when we're solving is to isolate the variable, the unknown. So we're going to use our algebraic processes to do that, and then we may or may not need our calculator to complete the solution. Okay, example 1, part A. It says state the exact solution to 5 to the power of x is equal to 8 and calculate its value to 3 decimal places. So the exact solution means we want to have it in its log form, and then the value, what it comes out as on the calculator. So we start with 5 to the power of x is equal to 8. Now we want to isolate x. In order to do that, we're going to convert this into log form. So remember, in log form, we're going to have our log base 5, and our exponential will be isolated. So what we're saying is that x is equal to log base 5 of 8. So this is our exact solution. To get our answer to 3 decimal places, we're going to do a squiggly equals. So x is approximately equal to. So we're going to say log base 5 of 8. And we get 1.292. 1.292 approximately. So nice and easy. There's our solution. When we look at part B, we have to calculate the exact value and the value to 3 decimal places of the solution to 2 to the power of 1 take x is equal to 6 to the power of x. Now this one's a little bit more complex. We could choose any base here. We could choose base 10, we could choose base 2, and so on. The problem is that we now have exponentials on each side. So we're going to have to slightly differ our approach. We're going to start by choosing a logarithm to apply to both sides. So let's say we log base 2 both sides. Choose log base 2 because that will allow us to bring this 1 take x down. So we say log base 2 of 2 to the power of 1 take x is equal to log base 2 of 6 to the power of x. Now if we apply our power law, then what we end up with on this side is 1 take x multiplied by log base 2 of 2. And on this side, we bring this x down, and we've got x log base 2 of 6. Now, log base 2 of 2 is 1, so we've got 1 take x is equal to x log base 2 of 6. Now, we need to get all the x values together. So if we add x to both sides, then we get 1 is equal to x log base 2 of 6 plus x. Now we'll have to take out x as a common factor, and we have 1 is equal to x log base 2 of 6 plus 1. And then finally, x will be equal to 1 over, because we can divide by this whole bracket, log base 2 of 6 plus 1. So this is our exact answer, and our approximate answer to 3 decimal places will be, we need to type this in. So we have 1 over log base 2 of 6 and plus 1. So we get 0.279. 0.279. Now it's 9 because we had to round this 8 up, because the value behind it is over 5. Okay. Now, if we weren't sure, and we looked at these two questions, I'm not sure if I got them right. Of course, with our calculator, we can check those. We can go Option, Calc, which is F4, and we can look at Solvan, which is F5. So if we type this in, 5 to the power of x is equal to 8, and we hit exe, it'll tell us there maybe is more solutions. We can ignore that, and we get 1.292. Look at that, we got it correct. And let's do it for the second one. Solve n 2 to the power of 1 take x is equal to 6 to the power of x, and it tells us there's maybe more solutions. We get 0.279. So we can see for each of those we were correct. So it's good to get in the practice of checking your answers, particularly getting fluent with this calculator and solving. Okay, example 2. We're trying to find x if log base 3 of 9 is equal to x take 2. So let's write this out. Log base 3 of 9 is equal to x take 2. Now, we're trying to isolate x. We should be able to see here straight away that we can write 9 in base 3. So I'm going to say this is log base 3 of 3 squared is equal to x take 2. So that becomes 2 times log base 3 of 3 is equal to x take 2. And log base 3 of 3 is 1, so we have 2 is equal to x take 2. From here, it's an easy solve. We can add 2 to both sides. We have 4 is equal to x, and therefore x is equal to 4. So there's our solution. A slightly different approach. We needed to simplify and evaluate before solving. The next example is a little bit more complex. Again, it will require some simplification before solving. We have log base 6 of x plus log base 6 of x take 1 is equal to 1. Now the first step is we need to be able to simplify. Use the skills we worked on last lesson. It's log base 6 of x plus log base 6 of x take 1. So they have a coefficient of 1. They have the same log base, so we can rewrite them using the product rule as log base 6 of x multiplied by x take 1 is equal to 1. Now straight away we have our base and our exponent. So we can say that this is x multiplied by x take 1 is equal to 6 to the power of 1. Or x squared take x is equal to 6. And if we bring this all over, hopefully we can recognize that this is a quadratic. And we've got x squared take x take 6 is equal to 0. Now, a, c, and b, we have negative 6 and we have negative 1. So it must be negative 3 multiplied by 2, negative 3 plus 2. And because it's a monic quadratic, we have x take 3 and x plus 2. Applying that null factor theorem, we end up with x is equal to 3 or x is equal to negative 2 as our solutions. Okay. In a scenario like this where we have two solutions, it's always handy to go back and put it into the original to make sure that it works, because sometimes these solutions come out, but they work for the product, but not for the original statement. So let's test them. So test, we have log base 6 of 3 plus log base 6 of 3 take 1 is equal to 1. Now, both of these values are positive, so they will work. So this one's fine. When we look at the second option, we've got log base 6 of negative 2 and log base 6 of 2. This negative, we can't have the log of a negative, will mean that it's impossible, and therefore that's not a valid solution. So our final answer is that x is equal to 3. Now, if we wanted to test that in our graphics calculator, let's type it on in. So we have solve n, and we need to go back and get our math and log. So we have log base 6 of x plus log base 6 of x take 1 is equal to 1, close our brackets, tells us there may be more solutions, and it gives us our answer of 3. Okay. So example 4 is a nice simple one. I'm going to show you it in 2 different approaches though, just so you understand that it can be done in different ways. We have 2 to the power of x is equal to 11. Now the simple one is, we use our log base 2. So we convert this to log form. We say the exponent is equal to log of base 2 of 11. So x will then be approximately log base 2 of 11. So 3.46 approximately. I'll fix up my squiggly equals, much better. Now the alternative is, you may not have a graphics calculator that has this log base function. So if we do everything in log base 10, so if we say on both sides we're going to log base 10, and when we write log base 10 we don't have to write a base, so we say log 2 to the power of x is equal to log of 11. Now using our power law, this becomes x log 2 is equal to log 11. We divide both sides by 2, we get log 11 over log 2. And then when we type that into our calculator, we can just use the normal log button now, log 11 over log 2, and we end up with 3.46 approximately. So 2 approaches, same outcome. This is the way that I was taught, because I didn't have a calculator that had the luxury of logs of different bases. Of course, you probably should become fluent with both methods, but either or will be fine for you to use. Okay, example 5. Solve 3 to the power of 2x take 1 is equal to 28. Now, of course, the idea is when we write this out, we have 3 to the power of 2x take 1 is equal to 28. If we convert this to log form, so the exponent 2x take 1 will be equivalent to log of the base of 28. So now we have 2x take 1 is equal to log base 3 of 28. If we add 1 to both sides, we get 2x is equal to log base 3 of 28 plus 1. And if we divide by 2, we get x is equal to log base 3 of 28 plus 1 on 2. Now, I'd be inclined to leave that as my answer, but if you want the decimal form, we can type that into our calculator, and we have log base 3 of 28 plus 1 divided by 2, and we've got an approximate answer of 2.02. Okay, our last example we're looking at in inequality. Remember that inequalities we solve in the same manner. We only have to worry if there are positive and negative scenarios. In this case, this won't be an issue. So we're looking at 0.7 to the power of x is greater than or equal to 0.3. I'm going to take log base 10 of both sides. So log base 10 of 0.7 to the power of x and log base 10 of 0.3. So this becomes x log base 10 of 0.7 is greater than or equal to log base 10 of 0.3. When we divide by log of 0.7, we get our final answer. So x is greater than or equal to log of 0.3 divided by log of 0.7, and we get approximately 3.38. So it's probably better to leave it in this exact form, because how do you write an inequality as an approximate inequality? But that concludes our lesson, and hopefully these skills are now something you can practice and continue to build your fluency with. All right, thank you for listening.